Hi, I've had a few requests recently asking how I make my head joints. So I'm going to make a series of videos, and this first installment will be how I draw the head joint tube. After drawing the tube, there will be forming the riser, making the lip plate assembly, getting it ready for soldering it on, cleaning and preparing the tube, polishing it, soldering them together, opening the hole, and finishing the head joint, final polishing, making the cork assembly, and the crown. Okay, our first job is to take this cylindrical tubing and we're going to form it into a taper eventually on this tapered mandrel. To begin, we need to use a cylindrical mandrel that only has a small tapered portion at the top that can round this over and fold it so we can capture it on the other arbor. So the tubing is a little bit longer than the arbor, so it will give us enough room to fold this over. There's two stations in this rounding die. The first one is just going to round it over. And you can see there's still some room here. But it hasn't been folded over yet. So now we want to go to the second station. Which is this side. And we're going to fold it over by the same method. And I rotate the tube as I'm doing this so that I make sure that it is perfectly concentric with the tube, because if it folds over unevenly, it will draw the tube in a crooked manner, so it will be like a banana. So you see now I've rounded over this edge and crimped it. I used to do this by quench annealing the tip and using this method, also quench annealing it and putting it in a lathe and using a power burnisher. But I've settled on this method. I use a half-hard tubing, and if you do this too quickly, you're going to get accordioning here or at the base. Now, since I have a good corner here, I'm going to be able to take my drawing mandrel and I'm going to be able to capture it, because the very tip is the same size as the tip of my arbor. And now I can go through a washer and this will hold it. If this has been made to be too thin or too fragile, it will tear going through. Albert Cooper told me that he used to go through a few draw plates and pre-draw this. I used to do something like that, and I found that my tubing had some visible transition marks in it. Now what I try to do is do it smoothly in one shot, not by pulling it through the way that I do when I'm drawing wire down, for instance, but by pushing it through, which aligns everything a lot better. The next step is drawing it through this cold rolled steel washer. As I mentioned before, I used to use a lead donut that I would make and machine the inside. And also I've used nylon or Delrin washers. And the problem I find with those is they don't draw as straight, and also sometimes they are prone to creating a pleat. And once there's a pleat at the very beginning, it irons that shape into the washer and it goes the whole length of the tube, and it can ruin a tube. So this nest that this sits in has to have a particular contour, and that contour must match the OD of a washer after it's been used. so that it fits in there securely and is supported. Otherwise, the washer will collapse in a non-uniform fashion and the drawing will not be as accurate. I've tried every kind of lubricant over the years, and with the exception of platinum tubes, which do require a special lubricant both inside and out because it's very prone to galling, the best lubricant that I've found is soap. I prefer ivory soap, something that has a decent fat content in it, and I will coat the entire tube with that. It's the best lubricant at preventing galling, and galling is when the two metals will create a scratch and an interference pattern. So I try to avoid that by moving very, very slowly. That's why I like to use a fairly slow draw, and I like it to be as even as possible. So the very tip of this has been drawn down slightly smaller than the end of this arbor. So I'm going to get a nice small beginning to this, and then I'm going to try to go very, very evenly as I go down the entire head joint. This is a repurposed log splitter, and they are available with an electric motor. This one had a gasoline motor that I removed, and I put on a 5 horsepower Baldor, but these are much superior to using an arbor press. Okay, now the tube has been drawn down and it is now tapered. But it's also stuck on the arbor, so now we need a way to get this off of the arbor. I'm now going to press the arbor out of the head joint. I have this tight-fitting bushing that's exactly the OD of this arbor, which is 0.747 inches. So I'm going to put it in here, and I can press the arbor out and remove it. And now we're ready to spot where the embouchure hole is going to be and to determine the length to cut it off. In order to find where to spot the embouchure to measure from, I use a plug gauge, and this diameter is 0.683, which is also 11.35 millimeters, which might seem familiar because that is the distance that we put the cork assembly from the center of the embouchure. So the diameter at the center of the embouchure is equal to the distance from the center of the embouchure to the cork plate. So I'll put this tool inside and matching right with the lineup plug is a sharp screw. So I'll take it and find that tight spot, and I'll mark it. And you can see that this screw lines up exactly with the center of this plug. So from there, I will take a length gauge and I will measure down from the center of the embouchure to the end of the tube and mark it. And then I will measure from the end of the tube to the top end. And once I've got this all measured out, then I need to cut it off. I'm going to cut off each end in the lathe, and I'm going to use a third arbor. This is my cutoff arbor. And I only have one portion here at the bottom and one portion here at the top that's going to fit tight, so it's easier to put on and off of the arbor, and it gives me enough clearance to cut this off at each end. I've got the cutoff arbor mounted in the lathe, and now I'm getting ready to cut it down. What I'm using here is an Enco lathe with 5C collets and a Aloris type tool holder. But in the past, I've done this with a jeweler saw, not under power, and also with a jeweler's saw, and spinning it on an arbor in a bench motor. I used to have a setup where I used a Sherline lathe with an extended bed, and I could cut off a full-size head joint tube in that kind of a setup. Whatever kind of a setup you have in your shop, you should probably be able to create some kind of a fixture for doing this accurately and safely. I like to make sure the cuts are chatter-free and that I've done it accurately and that the workpiece is being held securely. I like to burnish the outside and the inside just a little bit with my steel oiling tool, and that just reduces the burr. Now I've got this cut to length, and I can press this off of the arbor. And now I have my tubing cut to length. So I've cut the top end off, and I've also cut the bottom end off. And in this case, as I mentioned, this is a half-hard tubing, and now it's been hardened by physical reduction. So the part that got squeezed down has some memory, and it wants to return to its former size. And quench annealing, stress relieving, precipitation hardening, some of those things can alleviate this to an extent. It can change the temper of the head joint tubing, and it will have some effect on its response. For this head joint, I want it to be pretty spring hard, so I'm going to leave it as is. And you can see that when this was cut, it will spring open, even at the bottom end. This was the saw that was used, which is 14 thousandths of an inch, and it has a fair amount of spring. Likewise, the top has sprung open, really about the same amount, so that's kind of surprising considering this is the part that was squeezed down the most. If you heat treat or stress relieve the tubing, then the gap is almost equal exactly to the width of the saw here, meaning that it neither expanded nor contracted. The same thing with the top. So this kind of stress relieving is something that's generally done in a kiln. It can be done in a household oven for silver, something around 530 degrees Fahrenheit, which is pretty hot for a household oven, for an hour. I know people who use a torch and try to get this straw colored, but in general, if I'm going to heat treat something, I'll use a kiln so I have an exact temperature, and I change my time settings all the time as I'm keeping accurate records and finding how the results fared. Here I am in the polishing room. I've made a polishing arbor, and this is hardened steel. And this is going to protect the end of the tube from getting rounded over. And I've made a long threaded arbor to capture that. Now with the polishing wheel, they're very prone to getting some buildup on them. And that will look like this. This is an extreme example, but the ends of the fabric get flocked over with compound that's built up in a residue. So the first stage, usually of using any polishing tool, is to fluff it up. And I'm always repurposing things to use for this. I've made my own, like this one. This one is a pet grooming brush. All right, so to begin with, I'll use Tripoli. This is the brown compound. And as I said before, I want to keep crossing my angles. I'll work lengthwise as much as possible at a slight angle to the left, and then I'll work lengthwise with a slight angle to the right. I do very, very little crossways polishing because I can put in a dip so easily. And when I've finished enough of that, we'll do some lengthwise polishing. So it's starting to get a good surface. And then I'll work through a medium rouge wheel and then a final rouge wheel. And I use a number of different rouges. There's the Sunshine rouge, and then there's also some rouge available from Contenti and from Guess Wine. And I'm always using a different kind of rouge for a different stage of the process. My very, very final polish, I use the Sunshine rouge as it's really the most reflective. So I've been through all of these stages of polishing, the Tripoli and the rouge and the fine rouge, and I've gotten a good surface. As I'm checking it, I can look straight on and catch a reflection like off of a mirror. And then I can also sight down the tube, scanning a ray of light and looking for ripples or imperfections. So the last thing is I want to drill a hole where I had previously spotted the embouchure. And I'll do that with a jig, and I'll drill a number 53 drill hole, which is the pilot for a 172 screw. 172 is the standard screw that is found in most flutes. And I'm going to use that to screw on the lip plate assembly. So there you go. That is your first step, which is the drawn tube.